Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the rigid pavements and the pavement materials in detail. First, the rigid pavements. Rigid pavements have sufficient flexural strength in order to transmit the wheel load stresses to a wider area, to the area below, that is to the subgrade and the soil strata. As compared to the flexible pavement, the design of the rigid pavement is based on the flexural strength or the slab action, and they have the high flexural strength by the slab actions. The construction cost of the rigid pavement is high as compared to the flexible pavement, and it has more lifespan. The rigid pavement may be laid on the subgrade, and the thermal stresses which will be generated in this rigid pavement will be more as compared to the flexible pavement, as it cement is the major ingredient or material which is used in the construction of the rigid pavements. The expansion joints are needed due to this thermal stresses produced in the rigid pavements, and the strength of the rigid pavement, it does not rely or depend on the subgrade. An added advantage of the rigid pavement is that no rolling is needed of the pavement layers, and the road, that is the rigid pavement, it will be open for traffic after the 14 days of curing. Here in the rigid pavements, the force of friction is high in between the tire and that of the pavement, and these rigid pavements, they are not easily damaged by the oil or the chemicals. From the picture, we can see a cross section of a rigid pavement with the dowel bars provided in order to join the two rigid pavement layers. If you see the cross section, or we can see the components of the cement concrete pavement with the prepared subgrade at the bottom, followed by the drainage layer in order to drain out the water beneath the subbase course, which is also called as the dry lean concrete, as the DLC, and followed at the top, that is the paving quality concrete, abbreviated as PQC. Now we shall discuss the pavement materials in detail. First is the soils. Now, as we know that the pavement is being constructed by various types of materials, and these materials and their associated properties and their interaction, they will determine the properties of the resultant pavement. Thus, having a good understanding of these materials and knowing actually how they are being categorized and what actually will be their performance, or how the materials they will perform under the given loadings, will be able to understand the fundamentals in the design of the pavement. These materials, when they are used in the construction of an highway, they are of the intense interest of the highway engineer, as the types of material used and the properties of the materials used in the construction of the pavement will directly result in the performance of the pavement while it's being used, and it will also give the result, or we can say that it will also give us the usable span of the pavement. Now, the subgrade soils. The subgrade soils is important in deciding the thickness of the pavements. A subgrade with the low stability requires thicker pavements in order to protect it from the traffic loads. And the variations in the stability and volume of the subgrade soil with the moisture change are to be studied, as these properties are dependent on the soil characteristics. The stress strain behavior of the soil under the static and repeated loads have also its significance on the pavement performance to a great extent, and it depends on the subgrade soil properties and the drainage capability of the soil. From the figure, we can see the preparation of the subgrade soil. It has to be compacted well, and efficient material shall be used in order to drain out the water from the above layers. Now the soil types. A wide range of the soil types which are available for as in highway construction materials has made it obligatory on the part of the highway engineers in order to identify and classify the different soils. Now, broadly, these soil types they are categorized as the laterite soils, murum, red soil, desert sands, alluvial soils, clay, including the black cotton soils, etc. If you see the different, depending upon the different sizes of the material, they are classified as the gravel, the sand, the silt, and the clay. With first is the gravels. Gravels are the coarser materials with the particle size in the range under the size of 2.36 mm, and no fines are contributing to the cohesion of these materials. Next is the murum. The murums are the products of the decomposition and weathering of the pavement rocks. Uh, they are similar to the gravel except in the presence of the higher contents of fines. That means, as compared to the gravels, murum has the higher content of the fines. Next is the silt. Silts are finer than the sand. They are brighter in color as compared to the clay, and they exhibit little cohesion. When a lump of the silty soil is mixed with the water and alternately it is squeezed and tapped, a shiny surface will make its appearance on the surface. Thus, dilatancy is a specific property of such of the soils. That means the water it will ooze out at the surface of the silt, forming a shiny layer of the water. Lastly are the clays. Clays are finer than the silts. The clay soil will exhibit stickiness, high strength when they are dry, and they will show no dilatancy. The black cotton soil and other expansive soils they will exhibit swelling and shrinkage properties. And a paste of clay with the water when will be rubbed with the finger, it will leave the stains, which is not observed as in the case of the silts. Clays, here it should be noted that are is a type of a material which will cause the deformity to the pavements, as it can swell and shrink under the climatic conditions. So greater care should be taken by the engineers while designing of the pavement regarding the presence of the expansive soils beneath the subgrade of the pavement, and necessary corrective actions must be taken. With this, we shall stop here. Thank you.